Good morning, students. So today we are doing some more questions of question paper. This is a question paper of 2022, and this is not only for this particular university. We can watch the video for any of the paper of discrete mathematics. So the topic is today principle of mathematical induction. What is principle of mathematical induction and how to solve the questions I am going to show you in this video. So we are doing question number 10. Prove using mathematical induction that n square plus 5n plus 2 is even for all integers. So let us understand what the question is and then how to apply principle of mathematical induction. Let us paste it on another page. So the question is, prove using mathematical induction that n square plus 5n plus 2 is even. So first of all, understand what the question is. Illustration of the topic. They are saying that for n greater than or equal to 0 for all integers, means n can be 0, n can be 1, 2, 3, 4, 5 and so on. We are saying that if we take n square plus 5n plus 2 for any number, so let us start with 0. 0 square plus 5 into 0 plus 2. This is 2, which is even number. Okay. So if I put n equal to 1, 1 square plus 5 into 1 plus 2, which is equal to 5 plus 2, 7 and 1, 8. This is also even. Take any n. Let us take n equal to 9, suppose. 9 square plus 5 into 9 plus 2, which is equal to 81 plus 45 plus 2. It is also even. So whatever number n you take, this will come out to be even always. So you have to prove that this n square plus 5n is even for all integers. So you cannot say this using perfect induction method, means you cannot put for every n you are going to put up to 10 lakh suppose, or something big number, and you will check whether this is true or not. So we will use principle of mathematical induction for doing this. What principle of mathematical induction says that, let us suppose there are 3 steps in mathematical induction. First step says that prove the theorem for initial number. Okay, let us consider this as Pn. N square plus 5n plus 2 is even for all. Okay, for all is written as like this also. This symbol is for all n belongs to z positive. Okay, greater than or equal to 0, positive integers. Step 1 says that prove basis of induction. Prove the theorem for some initial number. Basis of induction means we will prove that at n equal to 0, suppose b0 will be 0 square plus 5 into 0 plus 2, which is equal to 2, and 2 is even. Therefore we will write that p0 is true. Next is step 2. Step 2 is induction hypothesis. Induction hypothesis. IH, it is generally written as IH. Induction hypothesis means we assume that theorem is true. Theorem Pn is true for all m less than n. For all m means we will assume that Pm is true. Pm will be m square plus 5m plus 2 is even. We assume this is true. We will take this as equation number 1. Now we will prove that in step 3. Step 3 is very important step. Step 1 and step 2 will give you only 3 marks out of 10. But if you do step 3, then you will get 7 marks out of 10. So total 10 marks out of 10. Step 3 is very important. Here we have to prove Pm plus 1 is also true whenever Pm is true. Means you have shown that for some initial number this is true, and when m is true then m plus 1 is true. That means if small number is true, then next number will be true. At 1 also it is true. If 1 is true, then 2 is true. If m is true, then m plus 1 is true. Then you can say that this will continue. This can be compared with dominoes process also. Dominoes means in which there are so many pieces of wood or walls, small wall. You put the pressure here, then they are going to drop each other. It will drop this one, this one, this one, and this one. Ultimately you can put the big wall on the ground. So this is also related to the principle of mathematical induction. Now we have to prove that Pm plus 1 is true. Pm plus 1 will say that m plus 1 whole square plus 5 times m plus 1 plus 2. Okay, you have to do nothing but you have to put here, you have to put m instead of n, you will get Pm, and then you will put m plus 1 instead of n, you will get Pm plus 1. You have to prove that this is equal to even, and even means if you can prove that this is equal to 2 times some integer. Okay, 2 times some integer is always even. So open this, you will get m square plus 1 plus 2m plus 5m plus 5 plus 2. Now we have equation number 1, m square plus 5m plus 2 is even. M square plus 5m plus 2 is even. So I will write even, or you can write, when some number is even, you can write that as 2 times k1, where k1 is any integer. And we are left with 2m plus 3, 2m plus 6. These numbers are left 1, 2m and 5. 2m plus 6. So we can take out 2 outside, m plus 3, and this is 2k1. This is already integer, and this is also coming out to be integer. So k1 plus m plus 3, and m is also integer, therefore m plus 3 will be integer, and k1 is also integer, so k1 plus m plus 3 will also be integer. Ultimately this is 2 times some integer number, which is going to be equal to even. Therefore theorem is true for n equal to m plus 1 also. Hence by principle of mathematical induction, theorem is true for all n. Okay, and n is integer. Done. So this is the method of principle of mathematical induction, in which we can prove any question. This is the question for proving this is even. We can prove any of the questions. So it's better if I give you one exercise also at the end of the question. As my habit, generally I give one exercise to every student. So for today your exercise will be, I'm giving you one more question for principle of mathematical induction. This is question number 10. I'm pasting here. This is question number 10 from paper 2021. Prove the following statement by principle of mathematical induction. I think this is 2021 exam. So do this question as a homework, and if possible, if there is doubt, ask in the comments. Thank you.